test review for blended algebra 2. All right, I don't think I do every problem on here, but I do a fair amount of them. So the first one says just evaluate g of x equals 18 times 3 to the x for g of negative 2. So you have to remember function notation back from unit 1. When you have a number inside the parentheses for function notation, that is an input, which is an x value. So that means our negative 2 is going to go in here for x. I would use Desmos. I would type in a Desmos 18 times 3 to the x power. And our exponent, we said, was negative 2. So when I type in negative 2 as my exponent, I get the answer of 2. And that's the whole problem. Right, the next one here, we're looking at numbers 7 and 8. So again, we skipped a lot of the multiple choice. If you need help on any of those other problems, see the key on Canvas or ask your teacher for some help. Number 7 says, an environmental firm is removing pollution from a riverbed. Right, if I'm removing something, it probably means that I'm decreasing or going down. There again, it finds the population is decreasing by 8% every month. Starts with 350. Which model represents this? So I want something that's decreasing. Remember, decreasing means that the growth rate is less than 1. So right away, I can eliminate B because its growth rate is bigger than 1. And I can eliminate D because its growth rate is bigger than 1. When I decrease by 8%, remember we always do 1 minus the percent, 1 minus 0.08. And if you don't know what 1 minus 0.08 is, use your calculator, 0.92. So we want 0.92 in our parentheses, which is option A. Number 8 is looking at the graph to the right. Which equation represents this graph? Well, some things you need to notice about the graph. It is increasing. So I want, it's increasing and it's exponential. So I can cross D off because it's not exponential. A, x squared, is not exponential. That's a parabola. So we're between C and B. Well, the growth rate in B is 2 to the x, and the other one's 1/2 to the x. If you're not sure, I'm letting you use your calculator here. Type into Desmos 2 to the x power, and then 1/2 to the x power. Oops, I did that one wrong. It's not parentheses. Well, notice that the second graph is decreasing, it's going down, and I want it increasing, like my picture, so I want that first equation. So it would be y equals 2 to the x. Use your resources, use Desmos, use your calculator when you need. All right, flipping over to number 9 here. It's a table, you're matching an equation to the table, which is modeling the data set. Well, if I look at x equals 0, that's the starting value or the y-intercept. I know I start at 2. So I can immediately eliminate B and D because their starting values are at 5 and 10. I can actually also eliminate C because its starting value is at 5. So really, I know A has to be the answer based on the y-intercept. Let's talk about the other reason why. This model is going up, and to get from 2 to 10, I multiply by 5. 10 to 50, I'm multiplying by 5, on and on. So that's the growth rate of 5 in the parentheses. I start at 2, multiply by 5 over and over again. All right, let's look at some free response. We're skipping down to number 12. A tub starts with 20 gallons of water. Every minute, half of the water drains away. Well, here's the model. Y equals. I'm starting with 20 gallons. Now, if half of my water goes away, that's not percent change. It's just saying half of it goes away. So you can put 1/2 in your parentheses here to the x power. Now, in how many hours will there be less than 2 gallons left? This is where Desmos and the table can help you. So go ahead and type your equation in. Y equals 20 times 1/2 to the x. All right? Ooh, I didn't do my exponent. 2 to the x power. There we go. Well, I'm going to make a table because I want to know when does the amount of water on the right column in the y get less than 2. So I'm going to keep making my table here. I'm not quite to 2 yet at 3. At time 4, I'm under 2 hours. So it's going to take about 4 minutes until there's less than 2 gallons of water in the tub. So that'll be 1.2. All right. Number 13. Do C and D here. We're just identifying information. So the y-intercept, that's also called the starting amount. The starting amount for this value, or the equation in C, is 12. Because the growth rate here is bigger than 1, we're increasing. Now to decide what you're increasing by, when it's 1.02, when there's a 1 there, you cover up the 1, and it's the percent after. 0.02 is equal to 2% change. All right, and then D, I think, is on the next page. Yep, sorry, mine was out of order. Number D, letter D, our starting amount is 87, that's the first number. The 1.97 is greater than 1. So we cover up the 1, have 0.97, we're increasing, and that's going to be increasing by 97%. All right, let's keep going here. Number 14. Biology classes at Hayes are studying fruit flies. Their observation starts with 60 flies, and the fruit flies are going to triple every day. How many flies are there after 5 days? Well, if I'm tripling, that means that my value of flies is going to increase. Now the model, well, I start with 60 flies, and tripling means you're multiplying by 3. Now I want to know how many flies there are after 5 days. That's the exponent. So in my calculator, I'm going to take 60 times 3 to the 5th. And it looks like I'll have 14,580 flies in 5 days, which is a lot of fruit flies. Number 17. The value of a car can be modeled by that equation. T is the number of years since you bought the car. Is it growth or decay? Well, first of all, the number in the parentheses, the 0.79, is less than 1. So this model is going down. It is decaying. What is the percent you decay by? Now, back in the notes, we said to determine the percent you decay by, you take 1 minus the number in the parentheses. So when it has a 1 in front, you cover up the 1, and that's the percent. When you're less than 1, you have to subtract the number in the parentheses from it. So let's do the math here. 1 minus 0.79, which is 0.21, 21%. So the value of your car is going down by 21% every year. How much is the car initially? Well, it's worth the starting amount, $22,300. And we want to know how much is the car worth after 8 years. So the value of the car, there, after 8 years is $22,300 times 0.79 to the 8th. So we're going to type this into Desmos, and we'll round to 2 decimal places because we're talking about money. And we get a value of $3,383.15. So in 8 years, your car is only worth a little over $3,300. Yep. All right, next problem, number 18. The amount of money on a credit card can be modeled by this equation. Is it growth or decay? Well, we have a growth rate of 1.07, which is greater than 1, which means that the model is growing. What's the percent you grow by? Well, remember, when I have a 1 point, I can cover up the 1 and see that the 0.07 after is the increasing, 7%. What's the initial charge you make on your credit card? Well, that's the starting amount here, $320. Now, suppose you have interest paying on your credit card. You do not pay any money on it. You do not pay down your $320 bill for 24 months, which is 2 years. How much money will you then owe the credit card? So the amount you will owe in 24 months is equal to your equation to the 24th power. And all you have to do is type that into Desmos. And find your answer. So 1.07 to the 24th power. And it looks like after 2 years, that $320 bill turned into $1,623.16. So, moral of the story, pay your credit card bills off that same month. Otherwise, I know it's going to take 2 years to get to that amount, but a $300 bill turned into $1,600, which is a lot more money. Alright, that was it for the video of the review. If you have questions on any other problems, ask your teacher for help and check the key on campus.